Hello everyone, today we will continue with the software installation with Voron. First we need to install Octoprint. By the way, I will use this guide to complete the steps. I will share the link. Again, it's coming from the Voron development team. First we need to install Octoprint. For that you need to install Octoprint from its official website. Here you can download it. Then put your SD card in the card reader and plug in the USB. Then we need to format the card. Select your SD card in here. It should automatically select it normally, but check it and format it. It is asking that it will erase all the data on it, so that's okay. After formatting it, we want to copy our image file on the SD card. In here, select your Octoprint image. Then in here, select your SD card path. Then click on write. Say yes. So it will take time. Now it's saying the writing is complete. Hit OK. In the Explorer, open your SD card. And here you will find octopi-wpa-supplicant. Open that text file. In here we need to add our Wi-Fi configuration, Wi-Fi SSID and password. The 99% of you guys using WPA modem, I'm guessing. If you are using WEP, for example, you should change, I think, your modem. It's not safe anymore. So we need to uncomment these 4 lines. Don't forget to uncomment this one, this bracket. Then here, put your SSID, your Wi-Fi SSID, Wi-Fi name, and put your password in here. After that, hit save and close your text file and eject your SD card. Then put your SD card on the Raspberry Pi and power your printer. Now we need to connect our Octoprint, our Raspberry Pi via SSH. For that I am using Mobile Xterm. You can use PuTTY and other software also, but I'm using that one. Basically, you can figure out the user interface, I'm guessing. For Mobile Xterm, you need to create a new session. I will use SSH, and since I don't know the IP address of my Raspberry Pi, I will use the local name and remote host octopi local. If it's not connecting with this remote host name to your Raspberry Pi, you can check your modem user interface and see the connected devices. So in there you should see a connected device which is named with octopi. So corresponding IP of this name is your IP address of your Raspberry Pi. So you can also use this IP address. You can also type the IP address in here and click OK. And that time it should be connecting. So since we didn't create anything, we didn't change anything in the Pi, the default username is Pi and default password is Raspberry. Since I want to change my password in the future, I don't want to save it right now. First thing I advise you to do, assign a static IP address of your Raspberry Pi. So in next time you can easily connect your device. So for that, we need to edit the dhcpcd config file. So for that, we need to put sudo nano and the config file. It's under etc folder, dhcpcd.conf. In here, you can easily uncomment this interface static IP address. So I'm not using IP6, so it can remain commented, and static routers and domain name. So as interface, if you are using Ethernet, it should remain ETH0, but I will use wireless. For wireless, we are putting VLAN 0, and in the static IP address section, we need to put the IP address which will be the static one. So I want to assign it 178, 24 should be remaining there, and for the static routers it should be your gateway address, your modem address. It's same in here, it should be gateway address, and you can delete this. Yeah, so you need to be careful, you can only change these last 3 digits. So with that you can easily access your Pi. Now we will say Ctrl X and hit Y to save the changes. Yes. And now let's reboot it. My Raspberry Pi is restarted. We need to log in again. Another thing you need to do before you download new software in your Raspberry Pi, you should update and upgrade your OS. So sudo apt-get update -y. This y means is it's accepting everything if in the process if there is some questions. So it will buy you a time bit. It will not hang on in the question if you go away from your computer. Now we need to do upgrade. So apt-get upgrade and -y. So this will take time. Our upgrade is also done. Like a style follow this. You can get the commands in here. Now we will install the Clipper. Now we are copying from the GitHub to our Raspberry Pi. Now with this command we will run the script. That script will do all required things to install Clipper. All package will be downloaded, etc. So it will do its thing. Now Clipper is also installed. We need to do a couple setting in the Octoprint. Now in here we need to create profile. Just follow the steps. We will go to the settings. And in here under serial connection, we need to add tmp/printer in here. We need to click save. Again, we need to go settings. In here, now we will select what we added before and again save it. Again, we need to go settings. Now we need to go to the behavior tab and we need to select cancel any ongoing prints but stay connected to the printer. Hit save. Now we will connect our printer. It's connected. You can suppress these temperature messages. Now we need to type status to see Clipper is there or not. Since we didn't put the config file, it's giving me this error which we were looking for right now. Right now we need to get this error. Now we will create firmware for our SKR boards. For that, again, I will follow the commands. We will go to the Clipper directory, make menu config. Yeah, here we will select LPC176XX, and since I'm using the normal 1.4, not the turbo, it will remain 1 megahertz. The target port should be enabled and communication should be again USB. Then we will hit Q to save it, press Y. Then we will say make clean. Now we will run make command. Yep, it's created the firmware file for us. Now we need to get it. We need to go to Clipper folder. It's under the out folder. Here it is clipper.bin. So right click and downloaded it. Then we need to change this file's name to firmware and we need to copy this file to our SD cards which came with the SKR boards. Copy these files to SD cards and power off your printer. Plug the SD cards to SKR boards, then again power your printer. Now we need to find our device IDs. For that, I already took them and noted down in the one text file. To get them, you need to run this command. It's again in the manual. But before running it, just unplug one of the SKR boards from the Raspberry Pi. For example, unplug your Z MCU and run this command. So while it's only plugged one of them, you will see only the plugged one. So note this, just copy this part. This is your device ID. So if you unplug your ZMCU, so remaining one will be your X, Y, and E MCU. Then after copying this in somewhere in some text file, unplug your X, Y, E and plug your ZMCU. Again, run this command. The other one will be your device ID of your ZMCU. Again, copy it to another text file. This both IDs. Then you need to install the config file for the Voron, and it can be found in the GitHub page of the Voron. So this is the default one. Now in here we need to adjustment for our printers. The first of it is the changing the MCU. So this is the like it's written. This is the MCU definition for the X, Y, and E. So I'm copying this device ID and pasting in here after by dash ID. So again, for the Z one, I am copying the device ID of the ZMCU, and under the related part, I'm pasting it. Now our MCUs are defined with the device ID. Now they can communicate with the Raspberry Pi once this config file is active. So next, we need to find the stepper X, which is that one. And in here, the all combination in here, but for example, I did 300 millimeter cube. So I will delete the other ones because I don't need them. And I will uncomment position end stop and position max. So I uncomment these both. And I will check my stepper. Yeah, I'm also using 2009. If you are using different one, you need to change this one also. And we will do the same thing for the stepper Y. Again, I'm building 300 millimeter cube. So I'm deleting the others. And I'm uncommenting position end stop and position max. And I'm checking my driver. Yeah, that's correct. So we need to go to stepper Z, which is here. Again, delete the unrelated ones. So, and uncomment the position max for the Z and check your stepper driver. So now I need to check stepper driver for the other Zs. So Z2, Z3. So all of them are configured as 2009, which is standard, which is also I'm using. I don't need to change anything in it there. Now we need to find extruder. Yeah, in here I need to see my sensor type is correct, which is correct. So I'm using ATC Semitech 104 GT2. So this is also correct for me. So I don't need to change anything. If you are using different, at the end of this config file, it's defined in here. And again, I am checking the driver, which is correct. Now we need to see the thermistor of the bed is correct. So it's correct for me. I'm already using NTC 100K beta for the bed. Check this one also. And we need to go to display section. So again, I'm using the VTT recommended. So it's not RepRap. So I'm deleting this one. Yeah, and I will uncomment the Mini 12864 since I'm using that one. Okay, so if there is a double DS, it's a command. Don't delete the double ones. So now my cable was short, so I couldn't connect my LCD to ZMCU. I plug my display to XY and extruder MCU. So because of that, I will change the pins by simply removing the Z in the pin definement. So if you plug your display in the Z motherboard, you don't need to do anything. Here you can select the color of your display, by the way. It's defined in here. The index 1 is for display, index 2 and 3 for the knob. Now I will change the direction pin for my Zs. I seen that I plug them reverse. So it's simple to change it. If there is an exclamation mark, delete it. If there is no exclamation mark, add 1 and Z0 and Z1 direction. So in here there is no. I will edit and Z2 I will delete it and Z3 I need to edit. So save your config file. Last thing you also need to do, it's under the quad gain tree level. Again, you need to select your what you are building. If it's 250, you need to uncomment these and delete these. But I'm building 300, so I will delete this one and this one, and I will uncomment this. Again, save it. Yeah, later on I will go through whole config and get used to it, because in the future I'm trying to add a couple mods, so I need to learn that. Now we need to copy this config file to our Raspberry Pi. For that, there are a lot of config file in the config folder under Clipper, but since we will not use them, I'm just deleting them. I will upload my config file in here, under the config folder. Text file should end with CFG. To upload it, go to Clipper and config folder, right click in there and upload, say upload the current folder. In the page you need to select what you want to upload. In our case it's a config files of ours. Now I upload there because it will be like a backup for us. So in the future, if you messed up, you can just again copy this file to your main branch. So we will copy it to correct path. For that, again, from the website orondesign.com, you can find this command, but I need to change this name because mine is, let me see, v24 score config, and hit enter. Yeah, now it should be added in the correspondent place. We'll connect our printer and we will say firmware restart. So it will send us a disconnect message, and yeah, ready. In 30 to 60 seconds, if you are not getting the Clipper state ready, type status, and in there it will point you to what's wrong with your config file. For example, display, you can just open your config file and see what is wrong and correct it. After that, again, you need to do firmware restart, then it should be okay. Now we are ready to commission our printer. First we need to do a couple checks. After that we will do the first homing. So for that, again, I will follow the guide from the Oron Design website. The link will be in the description. By the way, I already did this testing. I also did a couple mistakes. So in the video, I don't want to show you the wrong way. So that's why I did the commissioning of my printer and I successfully homed my printer. Luckily, they were minor issues. I will also mention my mistakes. So with that, you will be more careful about that, I'm guessing. Okay, first we will check our stepper motors. Are they working and are the directions are correct? We will start with the stepper X. For this commissioning test, the Clipper already has the macros, so it's very easy. So we will use this macro stepper buzz, stepper X. So we will say buzz the stepper and we want to test the stepper X. So once you send this command, your tool head should go right back about a millimeter. So it will go right back and come back the initial position. We'll do this couple times. So send this command and observe your tool head. So as you can see, our tool head right now is going to right back and coming back to the previous position itself. So that means if it's going to right back and come back, if it is continuous doing that, that means our direction is okay and our stepper motor is working. So we will do the same thing for the Y. For the Y, it will move about a millimeter, this time to front right. Again, send the command and observe your tool head. So I don't know if you can see it on the record, but my tool head right now is going to front right and coming back to its previous position. So that means the correction is okay. So X and Y steppers or A and B steppers, if your stepper is not moving to correct direction, front right for the Y and front back for the X, if these are not correct, we need to edit our config file. So for that, open your Notepad++. By the way, if you don't have it, I would recommend to you download the Notepad++, and it has a one plugin. I think this one is the name, MPPFTP. So with this, you can add your Raspberry Pi in here. So your IP address and port will be, of course, 2022, and connection type is FTP, and your username and your password. And if you connect your Raspberry Pi, so you will see the files in your Pi. So in here, for example, this is my config file in the Raspberry Pi. I'm just double clicking it and it's automatically opening in my computer. So in here, here is your stepper X. If your stepper X is not moving to rear right, so you need to inverse the direction pin. So for example, if mine X steppers is wrong, I should add just the exclamation mark to inverse the pin. So with that, you will change direction. The next time you are testing it, you will see it's going to correct direction. I already played with these directions, so mine should be like that. And if you change your config, anything, save your file. I will not save it since I don't want to change anything right now. But if you changed anything in here, save your file, then go to your Octoprint in terminal, send restart command. So it will restart the Clipper. So once it says Clipper state ready, it's ready to use again. Now we will test also the Z motors. By the way, I figure out that I labeled my Z motors wrong. So for example, I put Z label to Z3 motor. So because of that gave me an issue, but there is a nice screenshot in here. So take this as a reference. So somehow, because I think since I was busy with the wiring, I think I couldn't orient in my head correctly. So I labeled this Z3 steppers motor as a Z and Z2 as a Z1 and it goes on. But the correct one is the Z1 is Z0 is your front left stepper motor. Be careful about that. Be careful about your wiring, what I mean. So since my labels were wrong, my wiring was also wrong, but I quickly swapped the wiring in the motherboard. Now, for the Z, again, it will do the same thing. However, this time, of course, there is no, since this movement in the Z direction, this joint of your gantry will go up first and down. It will repeat this test a couple times. So again, send command and observe your front left joint. So, so it's going first up, then down, first up, then down. For the all Z motors, it should be doing this. So Z0 is finished. For now we will test Z1. By the way, if you press up arrow on your keyboard, terminal will call the latest command what you sent. It's like a prompter, command prompter. So again my Z1 was also going up first and down. Now we will test Z2. Yeah, it's also correct. Like I said, I already did, but I want to show you the correct way. Now we will test lastly Z3. Yeah, like I said, if there is a direction error in your stepper motors, go to your config file and change the direction input of your corresponded stepper motors. If there is an exclamation mark, remove it. If there is no exclamation mark, add exclamation mark. Save your config and restart your Clipper via terminal, then test it again. So then we need to do the end stop check. So again, there was an issue I have in the Y1. So if you remember, I was strongly advising you to wire the normally closed contact of your switch. The issue was I added a JST connector on the in the end stop holder for the XY, and it turns out while I'm plugging the male side of the JST, I mean the cable, one of the pin was moved to back, so it was not the one of the leg was not touching the JST connector, so it was not sending any signal to my motherboard. While I'm doing this test, it was always saying me to the Y is triggered. However, it was not. So there was something wrong, and I see that, like I said, the pin was moved back, and I corrected it, and after that it became okay. However, if I use normally open contact in the switch, I couldn't know that in the first place. I couldn't know that there is something wrong, because since it is normally open, it will say me that this Y is also open once it's not occupied, which is okay. But later on, if I try to test with this condition, in the faulty condition, and it will hit the, for example, when I try to G28 to home printer, it will hit the Y back country, back frame, and since, okay, the switch will be physically triggered, however, there will be no signal since our cable is not touching the connector inside, the pin of the connector inside. It will not send the signal to motherboard, and motherboard wouldn't know that it's hit it. So with that, I prevent my first major mistake. So in the switch, use your normally closed contact. So if there is something wrong, you can easily recognize it, like I explained. Okay, back to topic. Now, again, there is a query for that. There is a macro for that. We will send query and stop. So right now, as you can see, also my pins are free. They are not clicked, so they are open. Now I will try to hit X and send command. Yeah, if you see query returns as a X triggered, which is correct. Now we will try Y. Now, as you can see, while I'm pressing it, it's also sending me triggered. Now we will test Z. Yeah. As you can see, Z is also working. And another remark about the Z. I had an issue. The rod came with the kit. Was when I measured it, it was 30 millimeter, as I remember, and in the manual or the Discord, I don't remember the source. It was saying that it needs to be 33 if I'm using magnetic sheet. However, then I changed my rod, as you remember. However, I after installing everything in the magnetic sheet also, I checked the height of my Z pin, and it was way higher. So I tried the old one with that came with the kit, and it seems it's like it should be. So 30 millimeter was working okay with the magnetic sheet also in my case. What I'm trying to say, also before doing anything about Z, check your Z pin also. It should be uh, approximately 2 millimeter high from your bed, as I remember. Yeah, it is also documented in the Z end stop. You will see that. But check it with your eye and take an correct action. So end stop is also finished. Now, since our stepper and switch are seems okay, we can try to home our printer. But of course, we will not do for the Z. We will first try the X and Y. And for that, we need to send G28. If you say X, it will home only X. If you say Y, it will home only Y. But before doing that, you need to be ready to interrupt the action of your printer, interrupt the movements. So for that, I don't know which one is easier for you. Find a convenient one. You can use this stop button. It will interrupt. And another thing, you can just use your switch on your power plug, on your power skirt. And another thing is you can use the button in your LCD screen, which is it is just under the knob. There are all these three, or you can set M112, yeah, 112 in the terminal. So find the most suitable one for you and be prepared to press it or send the command, whatever you are choosing. So now let's home x-axis first. Like I said, be prepared to interrupt the action. So let's see. Yeah, yeah. If like I said, if your switches are working and if your steppers are working in the correct direction, you shouldn't also see any issue. Now I will try the y-axis. So by the way, when you send home command G28, it will lift up your Z for preventing any incidents. It's normal. Yeah, Y also homed. So these are working for us. So yeah, also there is an explanation for the directions. But yeah, just using stepper buzzer and observe it, it will be fine. You don't need to lost in this document. You need to adjust your bed position, location of your bed position. So for that, again, we already homed our toolhead, but it will not hurt. Just home it again for the X and Y only. Then first we need to position our Z and stop. So for that we will use our control panel. In here, since we homed our X and Y, we can use these arrows to move our head. So with using these arrows, these commands, we will position our nozzle just tap on our Z and stop pin. But be careful about this thing. So right now it's 100. So when I press it, it will go 100 millimeter. Especially be careful about these parameters in your Z. Yeah, just position your nozzle in your Z and stop. Just tap on the Z and stop pin for the only X and Y axis. For the Y direction, look at your printer at the left or right side and try to orient it on the top of the Z nozzle. And for the X-axis, look at your printer at the front and try to orientate your X position. So it's in position right now, and now we will learn where our nozzle. So for that, we need to send M114. This will give us the location of your nozzle, our head. So it is 210 for the X and 300 for the Y. We will take these values and we will open our config. In here we need to find save Z home. So this one. So in the home XY position, we want to change the X value in here, replace the X value in here, what you read in your terminal, and the Y value in here. So like I said, mine is already did. I roughly did now to show you. So change this of yours and save it, save your config file and restart your clipper. Your ZN stub should be placed in the YMax in your printer, which means you can just put your bed and you already placed your ZN stub. So once your tool head goes back till the end, so it will not move back to Y direction, the back side anymore. So that is your Y max. It's handy to have your ZN stop in this position for the Y direction. In this place, lock your screw, tighten your screws of your ZN stop housing, and after that, align your nozzle on your ZN stop. So mine Y travel is 300. That means I think I'm losing a 5 or 10 millimeter in my build space. It's related about my aluminum bed. I mentioned that my aluminum bed is a 305 millimeter instead of 300. So like I said, I'm still okay with it. So it will be fine for me if it is less a centimeter or 10 millimeter is smaller, but it's okay with me. So it's not a problem for me. So yeah, my Y max is 300 right now. Yeah, and yeah, like I said, lock your tighten your screws of your Z housing, then there should be a gap about 2-3 millimeter between your Z end stop and your aluminum bed. But this distance should be between the pulley which we placed in the printed part, not the pin. There should be a distance between the pulley and the aluminum bed. This is because we want to prevent the heat transfer between them. I mean, to heat transfer to the 10 stop, so it will not affect his performance, his accuracy. So there should be a gap. So after that, so since we say that our Z position also in our config, now we can home our printer. So again, be prepared to press any stop. So it's homing the X direction and it will make Y and it will go to the Z pin position and it will go down until the Z end stop is pressed. So in this process, if you see that it's not aligned with your nozzle is aligned the nozzle is not aligned with your pin, just press any stop and repeat this step again. So now we homed our printer successfully. So that's a good sign. Now we will continue with the defining our 0, 0 position for the bed. Like I said, first you need to position your Z end stop at the Y maximum. Then you need to learn that you need to learn the XY coordinate of your Z end position, and you need to change this in the config. If you do this step correctly, it will home your Z axis also successfully. Now, like I said, we will continue to defining our 0, 0 position. For that, again, we need to home our XY axis. So we will send G28 X space Y. I will just lift my Z a bit. So G1 is just the move command. So I'm saying move 5 millimeter on Z with speed 5000. Yeah, I lifted up. Now again we will use these controls. So now we will try to move our tool head to front left. So this is our 0, 0 position. When your tool head is not moving anymore to left or go towards you. So and if your aluminum bed is 3 to 5 millimeter away from the location, you need to play with your bed's position physically. Now, right now for me it's reaching my 0, 0 position. In this position, if your nozzle is just a millimeter away from your corners for your sides, it's okay, nothing needs to be changed. These offsets are within 5 millimeter. We need to calculate new position for our X and Y. We need to do probe check. For probe check, I would recommend to you use for example, you can use Allen key. First, check your probe is working or not. You need to run query probe for that. Run this one first. So it's not detecting anything. Put your Allen key under your probe. So you should also see the light is going off while it's detecting the metal. While there is a metal underneath, again run the query. Now it should say triggered if there is a metal underneath. If there is no problem with that, you can test our accuracy for the probe. For that, we need to go middle of our printer. So with G1 X150, since mine is 300 build, Y150 and Z, yeah, I will lift it up again for safety. So now it's in the middle. We'll run the probe accuracy query. So it will just do the measurements 10 times, I guess. So it will calculate the deviation Oh, it's very accurate. The deviation should be less than 0.003 millimeter. In my case, it's zero. I am that much lucky, or it's yeah. I will try again just for curiosity. Wow, turns out our Chinese clonophobe run is very accurate. Yeah, yeah. For the last four measurements, it's changed, and now the deviation is again under 0.003 millimeter. So our probe is also okay. Now, next thing we need to do PID tune. Before that, of course, we need to fix our bed, and for that, there's a small explanation. First of all, you want to do the measurements for the bed. For example, you need to measure the sides from the, yeah, you can measure it from the frame to bed for the sides. In that way, we want to put in its best position. So after that, when it's positioned, it's a good practice. Like it's explained, it's a good practice. Of course, your screws will be loose, so just tight one of them. Two of them just should be firm. Not tighten, but it should be firm. Developer teams that it's using three bolts instead of four, it's more convenient because if you tighten all four bolts and when you heat it up, the aluminum wants to actually, yeah, it will be under stressed because it needs to be changed. It needs to be expand itself a little bit, very less. But when you tighten all four sides, there will be no movement for it. So with that, you will see more bumps on your bed. More, yeah, it will affect your flatness of your bed in a bad way. It's recommended to use three bolts. Then, yeah, after doing the measurements from the side, from frame to bed, hit your aluminum, and wait for 10 minutes or 15 minutes. Then after that, tight one of the screw. Don't torque it, just tight a bit. The other two should be remain like just touching the aluminum surface. It's not snug, it's not loose. Somewhere in between, like a sweet spot for that. With that, there will be a little expansion tolerance for the aluminum bed once it's heated up. The documentation also advises the same when tightening the mounting screws for the bed. A good practice is to have one screw tight, two firm, and that last one is loose. So it should be done by hot. Yeah, it's best done hot. After fixing your bed, we need to do PID tune for the bed and hot end. However, since I will run this machine for only ABS, maybe just rarely I may use PLA. For that, I want to tune it for ABS. And for ABS, of course, I will use enclosure. For that, my plan is just enclose all the sides first, and after that, I will do the PID tune. I would recommend to use same. That was all for this episode, first episode of the commissioning. So in the next one, we will continue with the PID tuning. Feel free to ask if you have any question, and consider to be a subscriber of my channel if you like it. Yeah, see you on the next one.